So we are given this graph of f, and we're told that the integral from 1 to 3, so that means the area under the curve for this graph is worth 2.3. So let me go ahead and shade that in. From 1 to 3, so this amount right here, they're telling us that that is worth 2.3 units squared. They're telling us how much that is. And then I hate when they do this thing with the capital X and the lowercase, they're the capital F of X and the lowercase f of X. Let's just like ignore that for a second. All right, here's what they're asking us for. This is what they want. F of 3 minus f of 0. This should make you think fundamental theorem of calculus. We want an integral from 0 to 3 of this lowercase f function. So they're saying capital F is the antiderivative. Like if you do the derivative of lowercase f, you get capital F prime of X. Again, don't try to think about that too hard. I hate when they do that with the different capital and lowercase letters. It's annoying. Anyway, what they're asking for is the integral from 0 to 3. So we want the area under the curve from 0 to 3. Well, they gave us from 1 to 3. All that's left is this section. So hey guys, what is the area of this part? And good, 2. I was hoping for a few more responses there. It wasn't a trick question, guys. It's a rectangle, 1 by 2. So that's worth 2. You just add those together and you're gonna get 4.3. So that one is D as in delicious. All right, number 2. What they call this a piecewise linear graph. It just means a bunch of lines broken into pieces. Look, they're all line segments, all right? We want the value of the area under the curve from -1 to 4. So we're just gonna need the areas of these two trapezoids. And for once, they're right side up. The trapezoids are actually right side up. So we're gonna do 1/2 times the height of this one, that's 2, and then add the bases together. So this base along the bottom is 3, and then this one is 1. So that would be 4, double that is 8, half of that is 4. So this one is worth 4. And then we're gonna do the same thing for this trapezoid. So 1/2 times the height, and then add the bases together. So that'd be 2 plus 1. So that'd be 3/2, which would be 1.5, but I'm gonna label it as -1.5 because it is underneath the x-axis. So you'd have 4 and -1.5, that would give you 2.5, so B as in bubblegum. All right, number 3. This one is strange because you can't actually find the areas of these shapes. They're not trapezoids or triangles or rectangles or something. So whenever I go over this problem, I tend to just like make up an answer just for the sake of filling something in there. We're given the graph of f prime. F of 0 equals 0. It means like we're starting out with nothing here at 0. Like the origin is our beginning place. Which of the following has to be true? And when you do f of 0, that's going to be 0. They just told us that. F of 1, that means you've accumulated area from 0 to 1. So that's this amount right here, which I'm just going to call it 2. Let me make up numbers for all of these. I'm going to call that one 2. This little bump looks like it's a little bit bigger than that one, so I'm going to call it 3. And then this one's below, so it's going to be negative, and it's smaller than either of those, so I'm going to call it -1. I totally just made those numbers up. I totally just invented those, but this one's a little bit bigger than that one, and then this one's a little bit smaller. It's easier to talk about actual values than it is by going, well, this amount's a little bit bigger than that amount. If you call it something, it's easier to talk about. So I totally invented those numbers, but just go with it for the sake of getting through the problem. Right, so this is saying f of 0 is 0 is greater than f of 1. Well, if we go from 0 to 1, we've accumulated an area of 2, and 0 is not bigger than 2, so we don't want that one. All right, f of 2, so that means we're accumulating area from 0 all the way to 2. So that would be 2 plus 3 would be 5. And then greater than f of 1, which would just be this amount, which I called 2. So 5 is bigger than 2, we do want that one. And again, it's easier to talk about actual numbers. If I hadn't called them anything, we would just be saying, well, these two amounts together are bigger than this amount by itself. I just think it's easier to have a real number there. All right, f of 1, that would be from 0 to 1, so that would be 2. And they're saying that's greater than f of 3. So that would be now all of these. So 2 plus 3 would be 5, minus 1 would be 4. 2 is not bigger than 4, so we don't want that one. So this answer is B as in Barracuda. So again, I would just make up values for them. I think that's easier to wrap your head around than not having an actual number there. All right, so this is the graph of f. We have 3 line segments. Given above, g of x is this accumulation function. The accumulation begins at 1. So let me draw in a line here at 1. That's our starting place. All right, not 0. You have to start wherever they tell you to start. All right, compute g of 4 and g of negative 2. So we're just going to plug those into the function. So if you do g of 4, you want the accumulated area from 1 to 4. All right, so we're going to have to go and find these areas. Let me break this up here. So we have a trapezoid and 2 triangles. So this trapezoid's on its side. So 1/2 times the height, which is 1. And then I'm going to add the bases together, which would be 4 plus 1. So that's 5/2 or 2.5. And then the 2 triangles are going to cancel out. So like this one's a positive amount, that one's a negative amount. So this is just going to be, 2.5. But for the sake of being thorough, let's find those triangles anyway. 1/2 base times height. This one's going to be positive 1/2, and then this one's going to be negative 1/2. All right, and then g of negative 2. So if you plug in negative 2 for x, you want the area from 1 to negative 2. So that's going to be this triangle, but we're going backwards. So it's going to end up being opposite. It's going to end up being negative. All right, and so that triangle, 1/2 base times height. The base is 3, and the height is 4. So that's going to be worth 6. And so this answer is negative 6. Again, because we were starting at 1, going to negative 2, we went backwards. All right, so B says, find the instantaneous rate of change. I asked you guys this one already, this block. That means derivative. So we want the derivative of G at 1. So this is what they're asking for, is G of 1. That's their question. That is what they are asking us for. All right, so first let's find G prime, and then we'll be able to plug in 1. So if we do G prime, you're just going to plug x in for t. So that's going to give you f of x, which is this graph. This is the graph of f of x. So if we do G prime of 1, that's f of 1. And let me ask you guys that. Can you find f of 1 on this graph? I'm hoping for a few answers here. It's not a trick question. It's just 1 comma whatever. I'm just looking for the output there. If you plug in 1 on this graph, what are you going to get, guys? Good. Nice job. Perfect. Right here. 1, 4. Thank you. Just checking everybody's with me. All right. 1, 4. Cool. All right. C. Find the absolute minimum value on the interval -2 to 4. Absolute means it is the candidates test. So who are your candidates? And I don't need an actual value. I'm not just looking for a vocabulary word here. What any graph, what are going to be the candidates for your candidates test? Good, endpoints, and I'm going to call them critical points. In this case, it is going to be the zeros of the graph. You're totally right. Hoping for more answers there. Endpoints and critical points. All right, so our endpoints are -2 and 4. And then our critical point, and Maxwell's correct, it's the 0 because it's where the derivative equals 0. So it's going to be 3. So those are our candidates, and we're going to plug them into the function g. Now this problem was nice because they already had us do -2 and 4. We did those right here. So we plug in -2, we got -6. Plugged in 4, we got 2.5. All right, so we just need to go back and get 3. Remember, your accumulation starts at 1. So we're going to go from 1 to 3. So that would be these two areas here. So 2.5 plus a half would be 3. And they wanted the absolute minimum. So absolute minimum is -6 at x equals -2. And the justification is the chart. You don't have to write a because statement. So the chart acts as your justification. So that's all we need for that. All right, letter D. The second derivative of g is not defined at 1 and 2. Well, let's look. Here's 1 and here's 2. Why would we not be able to get a derivative at those points? Like, they're telling us we can't, but we should have known that anyway. How come? Like, why can't you get a derivative at 1 or 2? And yeah, good, perfect, sharp edge, not differentiable due to sharp edge, all right? How many of these values are x coordinates of points of inflection? All right, let me pull out my sticky note. All right, an inflection point means a change in concavity. That's where the derivative changes from increasing to decreasing or decreasing to increasing. So that's what we're looking for, is a change in this, okay? So it says how many of those are points of inflection justify your answer. So what do you think about 1? Yes or no? Is that going to be an inflection point? Good, yes. All right, so perfect. Now this is going to be a little bit of writing to say this. All right, so g of x has an inflection point at x equals 1 because g prime changes from increasing to decreasing there. All right, so 1 was a yes. 2 is a no because it doesn't have a change there. All right, so this one's going to be even longer to write. All right, g of x does not have an inflection point at x equals 2 because g prime does not change from increasing to decreasing or decreasing to increasing there. You're allowed to be annoyed by that, but you still have to write it. That's the only way to justify that. I've asked at readings where they go through how to grade the thing. I'm like, can't we like shorten that? And they're like, no, that's how you have to say it. So that's how you have to write it. It's not hard, it's just annoying. All right, we'll do 5 and then we'll take another little break. All right, so this is a word problem. This is about M&Ms. There are 250 M&Ms in a bowl at time 0. Now, when you're doing a story problem, something like this piece of information is what is called an initial condition. This is the initial condition. The initial condition is what you're starting with. So it says there are 250 M&Ms in a bowl at time 0. That's how many M&Ms you have initially. Is the initial condition. That's what you're starting with. That's like the official vocabulary for that. All right, the rate at which they are being devoured. Now, so since this is a rate, it's a rate of change, that's a derivative. So the derivative at which they are being devoured is given by E of t, E for eating, and it's M&Ms per minute. It's something per something else because it's a rate. So M&Ms per minute, they're being eaten at this function, M&Ms per minute. So how many M&Ms are in the bowl at time 3 minutes? Well, we started with 250, and we're going to subtract how many got eaten. How many got eaten is an accumulation. You're accumulating the number of eaten M&Ms. So that involves an integral. What are going to be the boundaries on our integral? We want to know how many got eaten in 3 minutes. So what are going to be the boundaries for this? Good, nice job, guys. 0 to 3. We're starting at 0 minutes. That's time 0, and we want to go to 3. And this is the function that goes inside of there. Now, when you type it in your calculator, you're going to type, negative x squared plus 12x. But on the AP exam, when you set up something like this, you just want to write E of t, number one, because it's faster. And number two, if you do a copy error, it'll be wrong. So just, write it that way. All right, we're gonna type that in. So 250 minus math 9, 0 to 3, and then again, you have to put in this function. So negative x squared plus 12x dx. So we had 250, we're subtracting out how many got eaten, and this is how many are left. So after 3 minutes, there are 205 M&Ms. So 205 left. So letter B, find the time at which the M&Ms are being eaten the fastest. Now it's being eaten, which is already a rate, the fastest. That is a maximum, and that should make you think critical points. Fastest is a maximum. We want to find a critical point. So we're going to get the derivative of this and set it equal to 0. Critical points are derivative equals 0. So being devoured, this is the rate at which they're being devoured. We want the rate to be a maximum. It's like a rate of change. We're going to do the derivative of this. That would be negative 2t plus 12. Set it equal to 0, and then we're just going to solve that. So subtract 12, and we get t equals 6 minutes. So at time 6 minutes, that's when they're being gobbled up the most quickly. That's when everybody is like, yum, 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 yum. All right, and then letter C, set up the integral equation that would give the time x at which the bowl empties. So that's when you have 0 M&Ms left. It's going to be really similar to letter A. At letter A, we found, how many M&Ms there were at a particular time. We just want the number of M&Ms to be 0. So we start out with 250, and we're going to subtract how many get eaten. Now, the boundaries would be from 0 to x. We don't know what time they're going to all be gone. That's what x would stand for. We don't know when that is. So we want to subtract off the number of M&Ms that got eaten. And if we want the bowl to be empty, we would set that equal to 0. None left. It means they are all gone. So you start with 250, you subtract off however many get eaten, and you want that to be nothing because it's asking when is the bowl empty.